Good evening, all. Is my voice is audible?
Yes, sir.
Fine. Yesterday I have discussed about the important concepts in the unit 4 and unit 5. So today I am going to wind up the computer organization, first, second, and third units. So all the important concepts. Okay. So are you able to see the screen? Yes or no?
Yes, sir.
So here that fourth and fifth unit. So completely we have the pin diagram and the instruction set addressing modes of the 8086 microprocessor. So mainly we are focusing on that. So as per my uh, expectation, so we'll get probably 30 to 35 marks from the last two units and remaining these two units. So I am going to cover. So total it was a 90 marks question paper. Okay. So all together. So here I am expecting remaining marks from these three units. So almost I covered all of the important concepts, whatever we have in these three units. So along with short and long answers, I wrote here. Okay. So the first one is if you have any queries during the session, you can ask me the queries. Okay. So I'm starting the explanation. So these are the important concept under the unit 1. So the whole long answers questions. So the first one is a basic computer organization. Some, Sometimes we are calling it as a block diagram of a computer, or sometimes, so we can expect the question, explain the different computer components. Okay, so what are the different computer components? Fine. What are the different computer components are there? So block diagram of a computer, at like in this we need to explain the input, output, and the memory unit and the central processing unit. Okay. So different. Uh, what are the input device? What are the output device? What are the memory? And what is the use of the central processing unit? And what is ALU? What is control unit? And these are all the things we need to explain under this basic computer organization. Okay. So this is for long answer, and sometimes you will get it for the 5 and sometimes you will get it for the 10 marks. So if it is a 5 marks question, just draw the block diagram of a computer and briefly explain it. If it is a 10 marks question, we need to explain each and everything. Input devices, you take some input device as example and we need to explain, and you need to take some output devices. For example, speakers, monitor, like that we need to take and we need to explain. When we are coming to the memory, primary, secondary, magnetic disk, each and everything we need to consider and we need to explain. If it is for elaborate the things. So whatever you are right, whatever you know in the uh, block diagram of a computer. So that is for the long answer you will get. Fine. And the next one is an instruction format based on internal organization. The questions are different. First of all, we need to understand the question. From this unit, so you can get one long answer and two short answer questions and one 5 marks question. So one long answer, that means 10, and one more half, that means 5, 15, and then 4. So around you will get 15 to 19 marks from this unit. Okay, 15 to 19. So I can say 17, like the 17 marks you will get from this unit. So here we have one common concept, but we need to understand the question. Instruction format based on internal organization. Instruction formats. Two questions are there. If he is asking us to write in, instruction format based on internal organization, we need to explain single accumulator, general register, and the stack organization. These are the three: single accumulator, general register, and the stack organization. We have the example. I already gave examples for this three topics in the unit 1. Okay, single accumulator, that means single accumulator means everything we will perform based on the accumulator values. Or moving or the getting data, everything will be in the form of accumulator only. It will only take care. General register means the general purpose registers we will use. Either it may be uh, either it may be bx, cx, dx, like that we will make use of the general register organization. We are calling it as a general register, sir. R1, R2, R3, R4, like that. R7 we will have, R0 to R7 we will have. So the general registers are R0, R1, R2, R3. So making use of general registers, like copying, move, for example, move R1 comma R2, like that we will write. This is general register organization. If you are making use of stack organization, it will have only two things: push and the pop. Okay, so push A, pop A, push B, pop B, like that you will just move the data. Fine. So these are the different instruction formats based on the internal organization. Are you clear? Are you following?
Yes, sir.
So here the instruction format based on the internal organization means either single accumulator you will make use of only AC register, and the general register is R0 to R7, and the stack organization is either we will go with the push and pop. Okay, so these are the three types you will use if you get the question from general instruction format based on the internal organization. And one more thing, this is most important question. 99% you can expect this question. What are the instruction formats? Okay, what are the, or explain different instruction formats. Okay, the question is explain different instruction formats. It is straight away question. If we want to ask you specify, if you specify, then only you can write the instruction format based on internal organization. If he is not specifying anything, then you should go with this question: 0 address, 1 address, 2 address, and 3 address. Okay. If he is not specifying anything, explain instruction formats. Then we need to explain the instruction formats with example. So all the examples I already gave in the notes. Okay. So all the examples I already gave in the notes. So just I'll show you. Yeah, here we have, you can see. So general, what is the question? Explain different instruction formats. You can see. So here we have, these are the single accumulator, general register, and stack organization. So examples we have here, as I told you, R1, R2, like R1 and add R1 comma X, like this we will use in the above formats. And now I am explaining this 3 address, 2 address, 1 address, and 0 address instruction format. This is most important question, and each and everything you can see one example, and we are evaluating one expression. Uh, we are evaluating one expression x equals to a plus b into c plus d. So this one we are going to evaluate in the form of 3 address and 2 address and 1 address and the 0 address instruction format. So if you get this question, you need to explain all these things. Okay, what is 3 address instruction format? Okay, what is 3 address instruction format? And what is 2 address instruction format? And we need to take one expression like this and we need to evaluate it. Sometimes you may get question like this. So a plus b into c plus d. Evaluate it in 3 address instruction format. Directly he will ask. Okay, or evaluate it in 2 address instruction format, or evaluate it in 1 address instruction format. Sometimes he will ask that instruction format only. Or if he is asking directly, straight away you'll get the long answer question. Okay, so we need to first identify the question, whether it is a straight away he is asking instruction formats, or else he is asking us to explain the uh, internal organization instruction formats. So what is going to ask? So you need to understand and you need to write that. Am I clear? Are you
Yes,
able to
sir.
see the screen?
Yes, sir.
Yes, sir.
Which one is there? 2 address? Are you able to
Two.
see the document?
Yes, sir.
Fine. And next. So any queries till now? Anyone is having any query? You can ask me if you have any queries.
No, sir.
Fine. So addressing modes with numeric example. So this yesterday also I told, if he is clearly specifying, I told one more thing as well. If it is a question from like if it is a 14th question, so then that question you can expect from which unit? If it is a 14th question, you can expect from which unit? I told right yesterday.
Fourth unit, sir.
It's from 4th unit. Okay, so now you have this addressing modes with numeric example. If it is a 11th question, isn't it? As per the logic, if it is a 11th question, you can expect it from the first unit. Yes or no?
Yes, sir.
It's from first unit. So then here we don't have that many things, just normal addressing modes. You will have direct, immediate, indirect, register, indirect. Okay, so imply that kind of addressing modes you will have in this. It's in the same way we will write here also immediate addressing mode, and we will have that immediate data in the operand. And example, move r1 comma or move a comma 0 to, like that you will have. Okay, so move r1 comma 0 to like that you will have normal examples. Okay, normal or basic examples you will have in this addressing mode. So here like you can see the addressing modes. So here we have, yeah, you can see here immediate addressing mode. So the register indirect, auto increment or auto decrement, and the direct addressing mode and the indirect addressing mode, relative and index addressing mode, base register index addressing mode. And along with that, we need to write this one also. So numerical example. Sometimes he will ask explain addressing modes with numerical example. So this we need to. Okay. So this numerical example. So it is already calculated. So program counter value and the register one and XR value. Okay. So the values which are there inside this table only he is going to take. Fine. Numerical example. If we specify only, we need to write this. Or else explain the addressing modes. Then this concept we can go. If we specify explain addressing modes of 8086, then we will go with the 8086 addressing modes. Are you clear?
Yes, sir.
Yes, sir.
Then write short notes on the subroutine. So it's a simple question, like if you know the just functionality of the procedures or the functions or the subroutines, then we can attempt this. Subroutines are like functions. These are just like the functions. Okay. So what are the instructions? We will mainly deal with the subroutine. So in the subroutines, the major instructions are the call and return. We will tell now function call and function return. In the same way, subroutine call and the subroutine return you will have. So that is just basic explanation what is subroutine. So if you want to perform the task, okay, so within the self-replicated within the block of statements. If you want to perform any specific task by placing all the statements under one common unit, that common unit we are calling it as a subroutine. Okay, so this subroutine will have two functions, subroutine call and subroutine return. Those are represented with the help of CALL call and RET return. Okay, so these are the two instructions. We will mainly deal with the subroutine. So subroutines are sometimes called as the interrupts also. So interrupts, we are calling it as an interrupt. Okay, so there is a basic explanation for the subroutine. You have any queries in this long answers? You can
No,
ask.
sir.
Clear, right? Shall I go to the short answer questions?
Yes, sir.
Fine. First one is the functions of CPU. What is the main function of CPU? Any idea? Any guesses? Fetch, decode, execute, store. These are the main functions of the CPU. So it is why we will use the CPU. The basic usage of the CPU is to take the input, process it, and give the output to the user and store the data inside it. So the basic usage of this one. So the principle which it is working, we are calling it as a fetch, decode, execute, and store. So those are the main functions of the CPU. Okay, you can expect 2 marks question. What are the different functions of CPU? Okay, and the CPU operations as well. What are the CPU operations? Like I told you now, just now I told you. What are the operations of CPU? Taking the data, processing it, okay, and giving the result to the user and storing the data back into the computer, isn't it? Memory. And input output device, you know very well. Input output device, I think no need of explaining this. What are the input and output devices? And same memory as well, primary and the secondary memory. Okay, RAM, ROM, and the magnetic disk, magnetic tapes. Okay, under this we need to write this. And types of RAMs. What are the different types of RAMs are there? Static RAM and the dynamic RAM. Okay, we need to write list out the different types of RAM, static and the dynamic RAM. What is the use of program counter? Tell me, what is the use of program counter?
Used to keep the address of next instruction
Yeah,
to
it
be
is.
fetched.
Yes. So it will keep the track of next instruction which we are going to execute. Fine. And the list out 4 functions of the CPU. What are the 4 functions? I told now only. What are the 4 functions?
getting the code from output, processing it, storing.
And one more is missing.
Decode.
Fetching, decoding, executing, and storing. Okay. So enlist are the list out program control instructions. Tell me, what are the program control instructions? Program control instructions.
Branch,
idea?
jump, skip,
Ah,
call,
yes.
return.
Yes, jump, skip, RET, break. Okay, so those are the program control instructions. Good. And next, the next. So here, write short notes or enlist conditional branch instructions. What are the conditional branch instructions? Tell me, what are the conditional branch instructions? So here you can see the program control instructions. Are you able to see program control instructions? Branch, jump, skip, call, return, compare, and test. So these are the program control instructions. So list out these program control instructions. And next, what are the status bit condition that control conditional control instructions? So down. So here, conditional branch instruction. So these are branch if zero, branch if not zero, branch if carry, branch if not carry. So based on the four flags. What are the four flags you will have in this? Four flags. What are the four flags in the basic computer? Zero, carry. I'll show you. Zero, carry, sign, and overflow. Okay. Carry, sign, zero, overflow. These are the four basic flags which we will use. Based on this, we have the conditional branch instruction. So list out the conditional branch instruction. So that is one more question you can expect. Okay, enlist, or I write short notes on conditional branch instructions. Okay, are you clear?
Yes, sir.
Fine. Then enlist subroutine instructions and stack instructions. What are the subroutine and stack instructions? Subroutines 2 you will have and the stack 2 you will have. What are they? Yes, no, I told na in subroutines.
Call and return instructions.
Call and return instructions in subroutine. And what are the instructions for stack?
Push and pop.
Push and pop. So those are the two instructions, isn't it? Those are the two instructions. Push and pop. So we need to enlist those two. So subroutine instruction 1 mark and stack instruction 1 mark. Fine. And what is interrupt, and list out different types of interrupts. Tell me what are the different types of interrupts? 3 interrupts are there. What are the last topic in the first unit? Internal interrupts, external interrupts, and software interrupts. So these are the 3 types of the interrupts we have: internal, external, and the software interrupts. What is an interrupt? When a processor is executing any program or during the execution of the program, if any other program, okay, if any other program is disturbing the normal flow of execution, then that we are calling it as a interrupt. If any other program is trying to disturb the normal flow of execution, then we are calling it as an interrupt. So these are the 3 types of interrupts: internal, external, and the software interrupts. Okay. And sometimes textbooks you can find software and hardware interrupts also. And in some textbooks you can find vector and non-vector interrupts. Okay. But as per your curriculum, you have 3 types of interrupts. Okay. Internal, external, and the software interrupts. Don't get confused with these things. Internal, external, and the software interrupts. You can find different types of interrupts also. Okay. So this is about the first unit. You have any queries, you can ask me the queries so that I can start the second unit. If you have any queries, or else I'll start the second unit. Anything to be discussed in the unit 1? Anything to be discussed in the unit 1, or you have any queries to me? No?
No, sir.
Okay. Shall I go to the second one?
Yes, sir.
Fine. So in this unit, the most important questions, like I marked with the red color. Okay. So this is a document I prepared long back. So which will have the 5 minutes importance, long and short answers, and in this most important I marked with the red color. Okay. So the first one is input output bus interface modules with a neat sketch. Okay, so here I'll show you the first one, just a basic basic bus diagram configuration. So here we'll have, so input output, this one, so connection of IO bus to the input devices. Fine. So basic input output organization, processor, and what is the need of using interface unit, and it will be a 2 marks question, what is the need of using interface. So I told you in the class, so the processor developed in the digital circuit format, and the keyboard and display terminal or the printer or magnetic disk will be developed in the form of electromechanical. Okay, so these two devices cannot communicate with each other, processor and the this electromechanical devices. Electronic device and electromechanical device, they cannot communicate with each other. So in order to provide the communication between these two, we are making use of one interface. So that interface will provide the support to the sending the data and receiving the data from the to and from the processor. So that is the use of the interface. So this will be the 2 marks question. What is the significance of interface module in input output bus organization? And this is a input output bus organization which we will use. So am I clear? Yes or no? You have any query here to ask me? Respond.
Your voice is getting breaks or in between.
Now is it clear? Still have any issue or else it is clear? Is anyone there?
Audible, sir.
Okay. So did you understand the concept of interface? Why we are making use of the interface? Are you able to listen me now? Anyone is out there? Kushali, Susmita, Shravani, are you able to listen me?
Sir, your voice is getting breaking, sir.
Now it is okay?
Yes, sir. Now it's okay.
Okay, fine. Fine. Okay, so here the IO bus interface modules, like we have the simple diagram and which we are making use of an interface for connecting the processor and the different devices, either it may be keyboard or the different kind of device we are making use of it. Okay, so in order to communicate with the processor, and here we are making use of an interface, so which is having the role to convert the electromechanical signal to electronic signals, so that the interface can provide the communication between the processor and the devices. So that is the significance of making use of interface. And the next one is like isolated versus memory mapped IO. Okay, so here if you are making use of, so this concept I think I have unstable connection maybe. So it is exiting directly. So stay with me 1 minute, so I'll fix it. Are you able to see the screen now? Is it audible? My voice is clear? Can anyone confirm? Are you there?
Sir, your voice is not audible, sir.
Now also it is not audible.